Here we'll be doing a geometric sequence. Let's say we have an example which is 3, 6, 12, and then times 2 is 12 times 2 over 24. Then it difference 6 divided by 3 it's 2, 12 divided by 6 is 2, 24 divided by 12 it's 2, common ratio. So with geometric we have a common ratio, so this means we divide our term 2 divided by term 1, term 3 divided by term 2. And then while in arithmetic we subtract, we're looking for the difference. Here we're looking for the ratio. So our term 1, we're only going to use the common ratio and the first term. Our term 1 will equals to 2, right? Sorry, will equals to 3. Our term 2 will equals to 3, which is the first term, multiplied by 2, which is the common ratio. Our term 3 will equals to 3 multiplied by the common ratio, and then multiplied by another common ratio. This will make what? 12. 3 times 2, 6 times 2 is 12. Term 4 will be the first term multiplied by the common ratio, multiplied by another common ratio, multiplied by another common ratio. So how many common ratios? They are 3. Here there are 2 common ratios, so I can remove this 2 times 2 and write 2 raised by 2. Here we have 2 raised by 1. So if you can notice the trend here, when it's term 2, there is a common ratio raised by 1. If when there is term 3, there is the common ratio is raised by 2. Term 4, the common ratio is raised by 3. Like the arithmetic one, let's say A is our first term, né? And then R is our common ratio. So meaning our first term will be A, because A is the first term. Our second term, now it's the first term multiplied by the common ratio, it means it's going to be AR. Our third term will be A. How many R's now? There are 2. So it's going to be AR squared. So if there is a 2, there is 1. If we're looking for term 3, AR is raised by 2. So if it's Tn now, we're looking for the nth term. We're looking for n. Tn will be AR. Utulo, it's like 3 minus 1, above nala 2 minus 1. So Tn will be n minus 1. Yeah? So this is our a formula for geometric sequence. So we apply it. Okay, let's get on to it. First things first, we look for the common ratio, and then, but since this is geometric, we know we're going to get the common ratio. Minus 1 divided by 2, it's minus 1 over 2. Half divided by minus 1, it's minus 1 over 2. So this means that we have Tn is equal to AR n minus 1. This is the formula. And then we should substitute the first term, which is A, and then R, which is the common ratio, and then everything will be set. So the first term is 2, then the common ratio is negative half, then it's all raised by minus, so n minus 1. So this is our general term, or this is our nth term. Let's go to the second one. First look for the common ratio. 8 divided by 2, it's 4. 32 divided by 8, it's 4. So now we put it on the formula. Tn is equal to ARn minus 1. And then our A first term is 2. Our R is 4. Then it's raised by minus 1. So this is how you get, or you find, the nth term of a geometric sequence. So we're just going to look at 2 examples where we look for Tn or where we look for n. Here we are given the sequence 2, 6, 18, and we are required to determine the 9th term of this sequence. And the following question we should determine sorry, which term will equals to 4374. So last number question out what different, you know. So whenever they say determine the 9th term, the 20th term, and so on, they are actually looking for T9. If they say the 20th term, they're looking for T20, right? But if they say which term will equals to, so it means that you are given Tn. Yeah? Let me just write the general formula here. Tn is equal to Arn minus 1. It means that you are given Tn and you should find n. You should find the position of 4374. Okay, let's get to it. Here we should determine the 9th term. So we know first things first, we should find the common ratio. Common ratio, it's the term, it's the second term divided by the first term, or the third term divided by the second term, or the fifth term divided by the fourth term, so on. No? So 6 divided by 2 is 3. 18 divided by 6 is also 3. So we have our first term, which is 2, our common ratio, which is 3, and then we can substitute 9 and where there is n, and then we're going to get our answer. So Tn is equal to A plus, it's Arn minus 1. So now we're looking for T9. It means where there is n, I should substitute 9. A is our first term, which is 2. R is our common ratio, which is 3. And then here, instead of n, I put 9 minus 1. And then we should get our answer. Let me just go to my calculator first. So it's 2, 3, and then it's 9 minus 1. 13, 1, 2, 2. Answer 13, 1, 2, 2. Right? You should never multiply 2 with 3. Yeah? Because the board must say we should start with the brackets and then order the exponent, the root, and so on before you can multiply. Yeah, so it should be 3 raised by 8 first, then the answer you multiply it with 2. Okay, yes, is another. Which term will equals to 4374? Which term will equals to 4374? Now our formula Tn is equal to Arn minus 1. Now we are given Tn, which is 4374. First term it's 2, common ratio it's 3. Then we have n minus 1, because we don't know the position of the term. In fact, we're looking for it. So here, solve n, so we should remove everything. So first we're going to remove the 2, and then we must bring down or drop the exponent, because the variable esisolvayo ilapha phezulu. So divide ngo-2, divide ngo-2 ke lower cancelelo ngapha kusele 3 raised by n minus 1. So 4374 divided by 2, we have 2187. So here we must make the bases the same. As I said, 3 raised by something. So I was checking local 3 raised by 7. 3 raised by 7. Now 3 raised by n minus 1. Drop, sala n 7 is equal to n minus 1. And therefore n will equals to n will equals to 8. So siyenza kanjena ke. Right, so here the last question for the geometric sequence, we should determine the number of terms. So let's say we have 2, 4, 8 ... Leli chaza ukuthini ukuthi ama-term aqhubeka wire yabo, asazi ukuthi agcinaphi, asazi ukuthi awungakhi. So 2, 4 ... means ukuthi nje aqhubeka wire, but la mabethi ... and then babhala inamba chaza ukuthi u-192, it doesn't mean ukuthi ama-term are 192, but it actually means ukuthi u-192 is our last term. So if your question is, we should determine the number of terms in the sequence. Then by like sequence, this is term 1, term 2, term 3, dot, dot, dot. Then see the last term. Since I'm a term, they always start with 1, right? If 192, since the last term, if you can get a position here, you took term 1. If 192 you term 30, it means with ama term is in our langaki out 30. So let's find out 92 to term 1. So here, obviously, so says the formula layer, and then let's in common ratio, we substitute. 92 is the value now. So meaning what we should find a position. Ne? Position ilapho esithola khona bani u-n, right? So we're gonna have Tn is equals to ARn minus 1, and then Tn 192. First term it's minus 3 over 8 UR 3 over 4 divided by minus 3 over 8, it's minus 2. Minus 3 over 2 divided by 3 over 4, it's also minus 2. So our common ratio is negative 2, and then we're going to have n minus a 1. So now we may solve it. So no minus 3 over 8, then we divide no minus 3 over 8. Divide that here is over no minus 2. Then 7 no n minus 1. So let me divide this side. It's 192 divided by 192 divided by negative 3 over 8. So we have negative 512. Negative 512. Then we should change 512. I mean, no base 2, so it's 512. It's 2 raised by 9. So it's going to be negative 2 raised by 9 equals to negative 2 raised by n minus 1. Then we drop. 9 is equals to n minus 1. N is equals to 10. So meaning, we can say now, therefore, there are 10 terms because the position for the last term is 10. Yeah?